let's start talk about a very important aspect of relational model. I would say this is the most important aspect, most important characteristic of a relation, which is the primary key, as well as the theory that the primary key is based upon, which is a functional dependency. The primary key, the concept of primary key basically is essential in that it's about the uniqueness of each tuple. Each tuple in the set, based on mathematical theory, each tuple in the set should be unique. A set is a group of data that is unique from each other, right? This is a theory. But this is not only a theory, it's also a natural result of a proper database design. If you think about the model we talked about, what is a tuple? A tuple is a mapping of real-world instance, while a relation is a mapping of a real-world thing, something in the real world. And in real world, all the instances are unique. You think about people. Think about student. Student A is different from student B, and as a human being, I'm different from you. You are different from him. He's different from her. Each individual is unique. You have a computer. I have a computer. These two computers are different. They're different in different aspects. The shape, mine may be a desktop, yours may be a laptop, and the brand may be different, the processor may be different, the memory may be different. All these are different and make everything unique, right? But as a mapping of real-world instance, tuple should also be unique because whatever real-world instance they are based on is unique. So there are students asking me, do you really need a primary key? And my answer is always, no, you do not need a primary key. But a primary key is the natural result of a proper design. So if you design your database properly, if you have your data set defined properly, you should naturally have a primary key. You don't need to force it. So this is why primary key is so important. It's important in theory and it's important in modeling. But then the question, of course, how to identify the primary key? How do you identify the uniqueness of a tuple? And it essentially goes to what determines the attribute value, right? And this is defined by functional dependency. Each object, each relation has a group of attributes. Usually there won't be any relation have only one or two attributes, right? Usually relations have each relation has a series of attributes. Like if you are a human being, you have your date of birth, you have your name, you have your social security number, and you have your height, weight, color of eye, color of hair. So all these are attributes that you can think of, but not all these attributes are equal. Some attributes are more unique than others. Like let's say the color of hair. Mine is black, and some other students, some student may have a black hair. Some student may have other colors of hairs, or like height. There might be a lot of people with the same height as mine, so it may not be as unique as a social security number can be. We defined these attributes and some attributes is more relevant to the uniqueness, and this attribute can determine other attributes. We define this as a functional dependency or functional determination. An attribute Y is functionally dependent on attribute X if and only if each X value is associated with precisely one Y value. So note here is X with the arrow to Y. This is how we write down functional dependency. That means knowing X value, you can immediately know Y's value. That means Y is depending on X, right? This is functional dependency. Y depending X to determine its value. And or the other way around, you can say functional determination. X will determine Y. When you know X, you will immediately know Y. While Y is dependent on X, you need X's value to determine Y. Either way, it's a functional dependency or functional determination, right? And also, as we said when we talked about composite attribute, functional dependency can also happen with a composite attribute, which means functional dependency can happen between a set of attributes and other sets of attributes. For example, here in US, right, all cars should have a plate. Like a plate has a number and has an issuing state. Now, let's say New Jersey 1, 2, 3, 4, 5. Let's say a car in New Jersey issued by the plate is issued by New Jersey NJ, and the plate number is 1, 2, 3, 4, 5, 6, 7. As soon as we know there's this is New Jersey 1, 2, 3, 4, 5, 6, 7. We know it's on which car it is. We know it's a Ford Mustang, a red car. So this is how you can see a set of attributes can determine other attributes, and those functionally dependent attributes form a set of dependent attributes, like car make, car model, car color, the Ford Mustang red, right? So there is a set of attributes that can functionally determine another set of attributes. Like if you know some student's social security number, you will know his or her name, address, date of birth, as long as you have the permission to access that, right? So like name, address, like which grade he or she is, and the course he taken. All this can be determined by the social security number of that student. So eventually, a set of attributes can functionally determine all the other attributes of the relation. When you have a set of attributes that can functionally determine all the attributes in the relation, we say this set of attributes can functionally determine the relation, right? Because if you can determine all the attributes, basically based on the uniqueness of tuple, you are determining that tuple and you are determining that relation. We call this, in this case, we call this set of attributes the key of this relation. The key means it can functionally determine the relation. Now, not all keys are created equal, however. Some key is more relevant than others. And here comes the idea of candidate key. Basically, what candidate key means is it's a candidate for a good key, for a good key. Why do we say that? Let's see what a candidate key is. A candidate key has two attributes, have two excuse me, two levels of definition. The first thing is the relation is functionally dependent on this set of attributes, or the other way around, candidate key functionally determines the relation. And second, there is no subset of the attributes for which one holds. What does that mean? I know it can be a little bit abstract. So let's see. For the second one. For these two groups of keys, let's say star, state, and the car plate can functionally determine the car, right? We already see that. How about state and the car plate and the car make? In fact, because state and the car plate alone can determine what car it is, so no matter what attribute you add, it's going to also determine what the car is. So state, car plate, car make can functionally determine the car. State, car plate, car model, or car color can also determine that car, right? When I say New Jersey 1, 2, 3, 4, 5, that car, I can also say it's a red New Jersey 1, 2, 3, 4, 5. But does this red or does this Ford provide me with any additional information or any real information? The answer is no, right? As long as we have state in car plate as a minimum set, we will know what the car is. We do not need to know anything else in order to determine that car. We do not need to know whether it's red, because the red itself is determined by state and car plate. So if there's an attribute that is not a part of another key, then this attribute should not be in the key. Or put it the other way, there's no subset of this key. There's no subset of this key can functionally determines the relation, which is the minimum requirement. That set of attribute by itself is the minimum you need to determine the relation. There's no subset in that can also serve as a key. That's a minimum requirement. If this key is minimum, then we call it a candidate key. And candidate for what? Candidate for primary key. Because if you think about it, there are a lot of times, there are a lot of possible candidate keys that you can use in order to determine the relation. For example, for a student, you have a student ID. You have a social security number. You have something like a name and address, right? Usually, in one address, there's only one person with the same name, with one name. If like in a household, there are like people with a different, with the same name, usually people will add something like senior or junior in order to distinguish between these two, right? So by definition, name and address in normal world, in most of the part of the world, name plus address is good enough to determine someone. And if you read like those ancient texts, they constantly refer to someone as someone name from some place, someone from some place, someone from some place. If you read those ancient texts, you've constantly run into this, and that's how people determine a specific person, determine the uniqueness of this person at the time without the social security number. So name plus address is a possible is a candidate key. Social security number is a candidate key, and ID, student ID, can also be a candidate key. So all these are candidates for primary key. They are candidate keys, and they are candidate for primary keys. But then, which one do you think is the best? Which one is the best key, best candidate key to use for primary key? Essentially, the answer to this question will go down to real world mapping. So which one, which ID, or which key looks more natural? And I think at this point, since you're a student, usually you naturally come with an ID, student ID, and a lot of systems are using that ID in their system. There are a lot of students, campus system, like library, like campus medical service, or like a dormitory service or dining service are associated with your student ID, right? Because usually you need your ID to enter the room, to enter your dorm, to go to your to go to a dining hall to get your meal plan. So student ID naturally is the mostly widely used attribute that you will run into every day. So that's a natural selection for primary key. Other than this primary conceptual consideration, this selection from the most natural one, there also is a practical consideration. Usually, we want to use integer or datetime as the key, because these are easier to sort, to search, whereas the text attributes are very costly in performing search or mapping or any other computation. So name plus address automatically goes away. Name and address must be some very long multi-field text, right? It's not the ideal primary key because it will cost a lot of computation. It's going to be a bad performer. Whereas ID and social security number looks more natural as a candidate for primary key. In fact, the social security number is a very common primary key in 20th century, like before year 2000. What happened after the year 2000 is that we have more and more internet, consumer-facing internet databases. So that comes with a concern of privacy and security. If you go to like financial legacy financial system for financial institute or insurance company, a lot of those legacy systems are still using social security number as the primary key. But these days, the newly designed system usually do not use social security number as primary key anymore. Example I listed here is what we call HICN and MBI. Basically, in the US, we have this federal government agency called the Medicare admin, which takes care of the medical service for senior citizens. Medicare admin used to use something called HICN, HICN, as the primary key for its database. This HICN is basically a social security number plus 2 more digits. So when you, if you are a Medicare recipient and you receive a letter from the social security admin, which has HICN on it, whoever sees this communication will immediately knows your social security number, which is also used for some other benefits. So this is the huge concern for privacy and for security. That's why the Medicare admin several years ago started to move away from HICN and use a randomly generated number called MBI instead of HICN as the primary key. So this is the example that you can see that the government agency used to use as a social security number as a primary key because it was a natural selection, but based on privacy and the security concerns, they're moving away and start to use something else. So these are the considerations that you may have for primary key and candidate key. When you try to write a shorthand representation, you will write, how do you signify that a field or an attribute or attributes are the primary key of the relation? You use the underscore. In most of the printing textbook, you will see underscore under each attribute of the primary key. Remember, primary key have a multiple attributes, right? If you have a state and the car license plate, then you should put an underscore under both state and the primary license plate number. But the problem with underscore is it has no problem in textbook, but when you are answering questions in a teaching environment, when students type this in some plain text editor, there's no like a notebook, like a notepad. There's no way you can put the underscore. So another way of signifying some attributes is a part of attribute key, primary key, is to put asterisk around that attribute, like what I just highlighted here. So this is how you represent the primary key in a shorthand representation.